Topic for this video is the quantum mechanical model. The essential question is, what is the quantum mechanical model of the atom? So we're going to talk about quantum mechanics, which is based on the dual nature of light and matter, and this is where chemistry and physics overlap. We're going to be comparing classical physics, which is before 1900, with modern physics, which is any time after 1900 up through today. So in classical physics, they believed that light consisted of waves. They acted like waves. Light reflects, it diffracts, it does a lot of things that waves do. However, in the modern physics, we have discovered that light also has properties of matter, and specifically photons. Photons are particles of light energy, and they can be released or absorbed as radiation. And so the evidence for that is the spectra. Particles, like electrons, are matter in the classical physics beliefs, and only like matter. In modern physics, we found that particles like electrons can behave like waves, and evidence for this is the diffraction of a beam of electrons. It behaves as a wave would when it is diffracted. Okay, so light as a particle is mostly supported by the photoelectric effect, and this comes from Albert Einstein. And he said that it takes light of a minimum frequency to eject electrons. So what's happening in that picture is that light is hitting a metal and it's sending off particles. So that would indicate that light has some sort of mass to be able to send out particles. Electron as a wave comes from Louis de Broglie, and he had a theory called the wave-particle duality. He ran an experiment where he release energy into some electrons, and he was able to see that they behaved like waves do and have several properties of waves. So in the modern model of the atom, it's based on the dual nature of light and matter, where light can be a wave and a particle, and electrons are particles and waves. Okay, so now we're going to talk about Erwin Schrödinger. And he is very famous for his cat experiment, and we'll talk about that in just a minute. But he did a lot of work with the quantum mechanical model of the atom. He was supporting the theory that electron behaves as a wave. And so his theory says that electron does not follow a definite path. Remember, we talked about Niels Bohr and how he had the electrons on orbits around the nucleus, just like planets go around the sun. Schrödinger said no, this isn't what's happening. He says that you can only tell where an electron is likely to be found. And the problem with Bohr's theory is that it only works with hydrogen, whereas Schrödinger's works for all the elements. So he says that you are likely to find them in the electron cloud or in the specific orbital that houses that electron. So we have different orbital shapes, and these are the different rooms where the electrons live. This is the s orbital, and you can think of S for sphere or spherical, and it only has one orientation, which means any way you turn it, there's only one way it can be because it's a sphere. Next we have the p orbitals, and they just pick random letters for this, and it has the shape of a dumbbell. And it actually is capable of having three orientations. So one goes on the x-axis, one goes on the y-axis, and this is 3D, so one goes on the z-axis. Next we have the d orbitals, and there are 5 orientations of those, and that's what they look like. And then we have the f orbital, and this is one example of the f orbital. They are really complex, but there are 7 orientations. So the cloud is most dense where the probability of finding electrons is the largest. So if you look at the cloud, it's most dense where it's darker in this picture, so as you get closer and closer to the nucleus, you're going to find more electrons. So now we're going to watch a quick video about Schrödinger's cat experiment.
I think this will be my seat.
Sheldon, do you have anything to say that has anything to do with, what I'm talking about?
Well, let's see. We might consider Schrödinger's cat.
Schrödinger. Is that the woman in 2A?
No, that's Mrs. Grossinger. And she doesn't have a cat. She has a Mexican hairless, annoying little animal. Yip, yip, yip.
Sheldon!
Sorry, you diverted me. Anyway, in 1935, Erwin Schrödinger, in an attempt to explain the Copenhagen interpretation of quantum physics, he proposed an experiment where a cat is placed in a box with a sealed vial of poison that will break open at a random time. Now, since no one knows when or if the poison has been released, until the box is opened, the cat can be thought of as both alive and dead.
I'm sorry, I don't get the point.
Well, of course you don't get it. I haven't made it yet. You have to be psychic to get it, and there's no such thing as psychic.
So then what's the point?
Just like Schrodinger's cat, your potential relationship with Leonard right now can be thought of as both good and bad. It is only by opening the box that you'll find out which it is.
Okay, so you're saying I should go out with Leonard.
No. Let me start again. In 1935,
Okay, so that was an explanation of Schrodinger's cat, and it was just basically a thought experiment. So he had hydrogen cyanide, and if you open the box, it would also trigger a release. So the basic idea behind this was that with the electrons, you can't ever really know for sure where it is, because what happens is if you shine a light, that light injects energy to the electron and it moves as soon as you see it. So that was how that related to Schrodinger's cat.